Right, here is our 4.6 lesson. It's titled Solve Inequalities Using Multiplication or Division. It's the next step in our process of solving all inequalities. It is the kind of parallel lesson to 4.2, which was solving equations using multiplication or division. Many of the same things are going to appear here on our strategies. There is, however, one major change that happens with inequalities, and specifically when we're talking about multiplying and dividing by negative numbers. And so we'll see that later in the video. Our learning target for this lesson is to be able to write and solve inequalities using multiplication or division. And our success criteria is this. I can apply the multiplication and division properties of inequality to produce equivalent inequalities. That is, using strategies like multiplying when we see division and division when we see multiplying in order to isolate variables or get variables all by themselves. Second success criteria would be that I can solve inequalities using multiplication or division. So again, that solving piece, how do I isolate or solve for my variable? And then finally, the last one is that I can apply inequalities involving multiplication or division to solve real-life problems. So being able to read a situation, see what's going on, and then create a inequality based upon the problem we see. All right, so again, inequality, we see this a lot. These are our four main ones: less than, greater than, less than or equal to, greater than or equal to. Again, we have these key phrases that we're looking for. The ones that definitely get highlighted and mixed up the most would be these. Again, we can think of each of these as like, what is it setting the boundary at? Okay, so if I see the word most, that means that my boundary is at the top, right? I can't go any more than that. For the other one, I see the word least, so that means I can't go any lower, meaning I have to be greater than or equal to that point right there. All right, our key idea. So again, there's actually going to be two different cases for this, and it has to do with what type of numbers are we working with. So in the case that we are multiplying by a positive number or dividing by a positive number, we can have the same property as we did equations, right? I can multiply both sides of the equation by the exact same number, and I get a still true inequality, right? So here I see -4 is less than 6. I can multiply both sides by 2, and I still get a true inequality that -8 is less than 12. Same thing for division. We can divide by the same number, positive number, and I still get a true inequality. We'll see what happens later with negatives and what the major change is. So for an example, we have this. It says solve x over 5 is less than or equal to -3, and then graph the solution. So I'm going to write this out. Again, our strategy is to think, what is going on? And then we're going to use the opposite of it to solve the inequality. I'm going to draw a line down the middle again to kind of separate our two sides. And what I'm going to note is that a variable is on the left side of the equation. It's right here. Okay, that means that's the side I need to get solved for that variable. And currently, I see that x is being divided by 5. Okay? When I see x is being divided by 5, I'm going to think, well, the opposite of division is multiplying. And so when I go here, I'm going to end up multiplying by what's on the bottom. In this case, it's 5. Now, it is important that you check, is the number I'm multiplying or dividing by a positive or a negative this time? In our first couple examples, they'll all be positive. We'll see then what happens when they're negative. Okay? By multiplying by 5, that kind of cancels these two 5s out. And on the bottom, I'm left with just x, which is what I wanted. I'm going to bring down my exact same inequality symbol. -3 times 5 results in -15. So I've solved my inequality. Now I need to graph it. I'm going to put my -15 on my number line here. I'm going to put in a couple more values just to show. Do you have to do this? No, but it might help kind of get a frame of reference of where we're at on a number line. Okay, I see that I have an equal to bar, meaning I can use -15 as an answer. And to show that, I'm going to use a closed circle on my number line. And then my alligator mouth, or the inequality symbol, is opening up towards the number which means that my x value needs to be smaller than it. Smaller values are always to the left, right? I know it looks like, right, -16, -17, that looks like the numbers are going up. Remember, when we're looking at negatives, that the further away you are from 0, the smaller you are. Okay. Second example here, what happens when there's a fraction attached, right? Again, we're using multiplication here. I'm going to draw my line down the middle. Now with fractions, I need to multiply by its reciprocal. This is the same as equations. We're going to do the same thing here. Okay? To get rid of 2/7, I'm going to multiply both sides by the reciprocal, or I'm going to multiply them by 7/2. And again, I'm going to do that to the other side, and I'm going to check, is the number I'm multiplying by a positive or a negative? If it's positive, which it is, I'm good to go. If it's a negative, we'll see what happens. Okay? What happens here? Well, 7's cancel, 2's cancel. I'm left with p is greater than, and then over here I'm going to write -4/1. I see that -4 and 2 can be simplified into -2 and 1, because I can divide both of those by 2. On the bottom I just get 1, so I know I'm going to have a whole number. -2 times 7 is -14. Okay, on my number line I'm going to show -14, -15, -16, -13, -12. This time I do not have an equal to bar underneath, meaning I cannot use -14 as an answer. So to show that, I'm going to use an open circle. And I want numbers greater than -14. When in the negatives, my biggest negative is the one closest to 0. So I want to go to the right. All right, here are 3 try problems. Practice your skills by multiplying again. We should be looking to do the opposite of what we see. All right, to start going through this, my first one, I have n divided by 3 is less than 1. Again, my opposite of division is multiplying, so I'm going to multiply by 3, and I'm going to multiply by 3. I'm going to stop and check. I'm multiplying by a positive. All good to go. Okay, so I have n left over here since these cancel. 1 times 3 is 3. On a number line, I'm going to use 3 as my value. I do not have an equal to bar underneath, so I can't use 3 as an answer, so I'm going to leave it in an open circle. And I want numbers that are smaller. Smaller numbers are to the left. We can also see that my inequality symbol is opening up towards the number, which means we have to go left on our number line. For number 2, I see m is being divided by 10, or m is over 10 in a fraction. To get rid of that, I'm going to multiply both sides by 10. Okay, multiply by 10 over here. What does that do for me? These cancel out. I'm left with m. And on the left-hand side, I have 10 times -0.5. If I go and do that, times 10, well, I get 0, 0, and then I get 5. So my answer here is 5. Positive times negative is negative. I get -5 is less than or equal to m. -5 becomes my value that I use on the bottom here. I can use it as a correct value, so I'm going to shade it in because there's an equal to bar. And my alligator mouth is opening up towards the letter, meaning I can use, I want numbers greater than it. Greater numbers are always to the right. Last one here, number 3. I see a fraction attached. I'm going to make this over 1 since I know I'm going to be dealing with fractions. To get rid of 2/3, I need to multiply it by its reciprocal. The reciprocal of 2/3 is 3/2. On the other side, I'm going to multiply over here by 3/2. These cancel out. I'm left with p. And then I'm going to keep my sign the same because I'm not multiplying or dividing by a negative. 3 times -3 is -9. 2 times 1 is 2. -9/2 I'm going to use as my answer. or I could simplify this to negative 4 and 1/2. Both of those are the same. I'm going to give it an open circle since I can't use it as an answer. It's there's no equal to bar underneath. And this time my mouth is opening towards the number, meaning I want numbers that are smaller. So I'm going to go to the left. All right, our example 2. Same thing now with division. Okay. I see 6x is greater than negative 18. For division, or for when I have a number that's directly attached to my variable, I need to do dividing, right? We can assume that there's a multiplication sign in between there. So here I'm going to divide both of these sides by my coefficient, or 6. These cancel out, I'm left with x. Negative 18 divided by 6 is negative 3. Again, I'm checking to see, am I dividing by positive or negative? Since I'm dividing by positive 6, I'm going to keep my sign the same. Here I've got negative 3 as my number that goes underneath. I do not have an equal to bar, so I'm going to have an open circle. And this time my x is the one that the mouth is opening towards, meaning I want numbers that are bigger than negative 3. So I'll have an arrow pointing right. Second example here, 3.2g is less than or equal than 8.4. Okay. Again, when I have something attached to a letter and there's no other signs in between, I'm going to assume multiplication, meaning to get rid of it, I'm going to divide by what I see. Dividing by 3.2 leaves me with this. 3.2 goes on the outside, 8.4 goes on the outside. We're going to move our decimal, both cases, once to the left or right, and I'm going to go from there. 32 can go into 84 twice. 32 times 2 is 64. We'll subtract that away. I get 20. I'm going to drop in a 0 on the bottom here. 32 into 200, I'm going to guess 7. That would be 4. That would be 224, so I'm a little high. Take away 32, I'll be under. I'm going to say this is 6. 32 times 6 then is 12, 192. We're going to subtract that away. I have to borrow here. This becomes 1, 9, and 10. I'm left with just 8, meaning I need to drop in another 0. 32 into 80 can only happen twice. And again, that was 64. Subtract that away, and I get 16. Drop in one more 0, 32 into 160. That can go in exactly 5 times. So I get an answer here of 2.625. On my number line, I'm going to use that as my reference value. I have an equal to bar underneath, so I'm going to shade it in, saying I can use that as an answer. My mouth is opening away from my variable, meaning I am going to want numbers smaller or to the left. All right, here's some try problems for you. Go ahead and try those out, and we'll go through them in a second. For number 4, I'm going to draw my line down the middle. I see 4 is attached to b through multiplication. We're going to divide it out. These cancel, I'm left with b. 2 divided by 4, well, 2/4 is an answer, but I can also simplify that to 1/2, or 0.5. Okay, I'm going to use 1/2 as my marker. I do have an equal to bar, so I can fill in my circle. My mouth is open towards my variable. I'm going to want numbers greater than 1/2. For the second one, again, I'm going to divide here because 12 is attached to k. By dividing by 12, I get k is less than or equal to, there are 2 12s that fit into 24. Negative divided by positive is negative. Negative 2 becomes my reference point. I do have an equal to bar, so I can fill it in. And I want want numbers that are smaller than -2 this time, so I'm going to go to the left. Last one is -15 is less than 2.5q. We're going to divide by 2.5, divide by 2.5. I'm going to set this up here. 15, we're going to move once, into 150. 25 can go into 150 a total of 6 times, and it does so evenly. So here I'm left with q and -6, because negative divided by positive is negative. My reference point is -6. I do not have an equal to bar, so I'm going to put an open circle. And my mouth is open towards q, meaning I want q to be bigger than -6. Bigger numbers are always to the right. All right, that leads us to the second case of today's lesson, okay? We sometimes often overlook this, but in inequalities, there's a strange thing that happens when we try and multiply or divide by a negative, okay? So here's kind of a situation. Say we have the inequality 1 is less than 3. That's true, right? 1 is less than 3. If I were to go and multiply each of these by a negative number, say -2, then something strange happens. -2 times 1 is -2. 3 times -2 is -6. If I look at the expression -2 is less than -6, and I think about that the greatest negative number is the one closest to 0, well, then this is actually a false statement. -2 should be bigger than -6. This is going to happen every single time you multiply or divide by a negative. Okay? So, our strategy that we have in math, it's just a property of inequality, okay, is when I multiply or divide by a negative number, I'm actually, in my answer, going to flip my sign. Okay? Anytime I multiply or divide by a negative number, I need to flip my inequality symbol, because now -2 is greater than -6. This is now a true statement. This works for any one of the inequality symbols. This works for either multiplying or dividing. And again, it's the number that I'm multiplying or dividing by, not necessarily if I get a negative answer or not. Okay, let's take a look at a quick situation here. So, suppose I have this, -3/2 n is less than or equal to 6. Okay. I know from before that in order to get rid of a fraction attached to a variable, I need to multiply it by its reciprocal. And again, because this is negative, to get rid of a negative or to end up with a positive n, I need to multiply this by -2/3. And I'm going to do that to both sides. Okay? Here's where our siren should go off with. If you ever see yourself multiplying or dividing by a negative, automatically we are going to flip our sign. Okay? What happens here? Well, these cancel. I'm left with just n. 6/1 times -2/3. I can do a little bit of simplifying first, and I end up with -4. Okay? To graph that solution, I see n is greater than -4. -4 is here. I get a closed circle because there's an equal to bar. And I'm using the sign at the end because I've flipped it. Okay? And this time I want n to be bigger because my alligator mouth is opening towards that, meaning I'm going to go towards this way. Sometimes, if you want, you can always check to see, does my answer make sense? Okay. Over here, I know eventually I'm going to hit 0. So what I'm going to do is I'm actually going to put in 0 and see, do I get a true statement here? Okay. If I plug in 0 for n, I get something like this. 0 times anything is just 0. And then I have to ask myself, is 0 less than or equal to -6? That is a true statement, meaning I know my arrow is pointing the correct way, because if 0 wasn't a solution, it should be pointing away from 0. But in this case, it is. Okay, a couple more examples here. The next one actually shows that dividing also has the exact same thing. We're going to change this really quick. This is going to become a -6n. Okay? And when I go through this, to get rid of the -6n, I'm going to divide by -6. There goes our alarms in our head. I'm dividing by a negative, meaning my sign is going to flip sides. Dividing by -6, I'm left with n. Negative divided by negative is positive. 6 can go into 42 7 times. 7 is my reference point. I'm going to use an open circle since there's no equal to bar. And because my inequality flipped, I'm looking for numbers that are greater than 7. So I'm going to go to the right. Number 14, we have another example. This time I'm going to multiply. I have a negative g over 8. To get rid of the over 8 part, I'm going to multiply this by 8. And again, to get rid of the negative, I'm also going to make this a -8. We'll do the same on the opposite side. Multiply this by -8. Alarm bells are going off. I'm multiplying by a negative number. So this means my sign needs to flip. -8 times 4 is -32. Here, I'm going to make that my reference point. I see an equal to bar. I'm going to fill it in. And again, my mouth is facing my variable, so I want numbers that are greater than -32. All right, there's going to be 2 pages of try-its. Try as many as you need. There'll be these 2, and then we'll do 2 more on the next one. All right, for number 7, I see that there's a -3 on the bottom, meaning to get rid of this, I need to multiply by -3 and multiply by -3. Alarm bells are going off. I'm multiplying by a negative. My sign needs to flip. X is left over here after those cancel out. -4 times -3 is +12. Coming here, 12 is my reference point. I cannot be equal to 12 since I don't have an equal to bar, so I get an open circle. And this time my variable is not being eaten by my alligator, it's eating the number, so I want numbers that are less than. In number 8, to get rid of this negative and the 2, I'm going to multiply by -2 and multiply by -2. When I multiply by a negative, my alarm bells go off. I need to flip my sign. Y, and then over here, -2 times 0.5. Well, that's half and that's 2. Those kind of are opposites of each other. I'm left with -1. -1 is my reference point. It is able to be equal to, so I'm going to shade in my circle. And again, my mouth is opening towards the number, not the letter, so I want numbers that are smaller. Here's another couple try problems. If you want, you can try these out. For the first one, 6/5 times m, right? To get rid of this, I'm going to multiply it by the reciprocal, which is 5/6. And over here, I'm going to make this 5/6. Now, it's a little bit of a trick. There is no negative attached here. Yes, there is a negative on negative 12, but that's not the number that I'm multiplying by. I'm multiplying by 5 over 6. So, because the number I'm multiplying by is positive, my sign remains the same. Only when I multiply or divide by a negative number does my sign flip. These cancel out. I'm left with m. Over here, I'm going to make this negative 12 over 1. Negative 12 and 6 can simplify to 1 and negative 2. 10 times negative 2 is, 5 times negative 2 is negative 10. Negative 10 becomes my reference. I can be equal to it since I see the equal to bar. Mouth is open towards the number, meaning I want numbers that are less than that number. For number 10, I can see that I have a negative 2/5 attached to h. I'm going to multiply this by negative 5 over 2. Negative 5 over 2. And this time my alarm bells are going off. I'm multiplying by a negative. I need to flip my sign. Those cancel. Those cancel. I'm left with h. Negative 8 and 2 can simplify to 1 and negative 4. Both of my numbers on the bottom are 1, so I'm going to get a whole number. Negative 4 times negative 5 is positive 20. 20 becomes my reference point. I can use 20 as an answer, so I'm going to fill in my circle. And this time my mouth opens towards my variable, so I'm going to go to the right. All right, now we're going to kind of get into that last part of the success criteria, which was using multiplication and division to solve real-life inequality problems. So our first one is this. The submersible descends 37.5 meters per minute from sea level to explore a recent shipwreck. The shipwreck rests on the ocean floor at an elevation deeper than negative 3,810 meters. That's where the elevation of the Titanic is. Ours is a little bit deeper than that. How long does it take the submersible to reach this shipwreck? Well, let's kind of look at some important things. Okay, I know that I descend 37.5 meters. Now the word descend is important here. If you're descending, that means you're going down. And to signify that, typically we use a negative. So this is going to be negative 37.5 meters per minute. Okay, and again, my question is asking how long. Typically, that means I'm missing a time. And in this time, I'm looking for minutes, so I'm going to use m. Right, it's 37.5 meters every single minute. If I knew how many minutes, then I could get there. So I'm going to use m as my variable. And I want it to be deeper than negative 3,810 meters. The word deeper, right, refers to a more negative number. And we know the further we go into the negatives, the smaller we get. So I want my total exploration to go deeper or to be less than, because of the fact that I am going farther down or further into the negatives than negative 3,810. Okay, so when it asks us to set it up, this is what we have. And now from here I can go about and solve. I'm going to draw my line down the middle. I'm going to divide by how many meters I can go every single minute so I can figure out, well, how many minutes do I need to get all the way down there. So I'm going to divide this by negative 37.5, divide by negative 37.5. Okay. Because I'm dividing by a negative, automatically in our heads we should be thinking, flip my sign. Okay. This kind of makes sense in this case if we think about it, like we want our minutes to be greater than a certain number, because the more time we spend going down, the deeper in the ocean we're going to get, which makes sense. Okay. When I go and divide these two, I'm going to set it up like so, 3810. Move my decimal, move my decimal. All right, 375 does not go into 3, does not go into 38, but it goes into 381 one time. And I'm left with 6. 375 does not go into 60, but it does go into 600 one time. That's a 5, that's a 9, that's a 10. I'm left with 5, 2, and 2. All right, I'm going to drop in a 0 after my decimal point to finish this up. 375 into 2,225. I'm going to guess that we can fit, let's say 5 in there. Okay, I get 25. That's 37. 5 times 3 is 15, plus 3 is 18. Okay, so 5 isn't quite enough. I'm going to add one more to see if we get there. This is 0. That is 5. That's going to be 12. And look at that, it goes in exactly 6 times. Okay, so here's what I know. The number of minutes it's going to take me to reach a point where I am deeper than negative 3,810 is 101.6 minutes. Okay, and again, I want to be more than that, or I want my minutes to be greater, because the longer I travel, the more I go, farther I go down, which is exactly what I want. Okay, if you're wondering, 0.6 minutes as a time, like in seconds, we could also say that my total number of minutes needs to be 101 minutes, and 0.6 in terms of minutes is 36 seconds. For a try problem, we have this one right here. I want you to see if you can work through it a little bit here. It says that you want to put up a fence that encloses the triangular region with an area that is greater than or equal to 60 square feet. Okay, and it's asking us to describe the possible values of C. Now what's going to be helpful here is to know the area of a triangle. Okay, the area of a triangle is this: base times height divided by 2. Okay, so take some time, think about what could I do to solve here. And again, we're trying to solve for that missing side length. Okay, so here's what we've got. I know that I have an area of a triangle that is greater than or equal to, meaning this space in here has to be more than or equal to 60 feet. Okay, so I know it's more than 60. Okay, now how do I solve for that area of the triangle? Well, it's the base times height divided by 2, except this time I see that my base is C, my height is 12, and then I'll divide it by 2. So to get C by itself, I can do a couple of things. One thing I notice right away is that this is technically like 12C over 2 is greater than 60. And then from here, 12 and 2 actually can simplify into just 6. So I have 6C is greater than 60. Okay. From here, right, to get C by itself, I'm just going to divide by 6, meaning my base of my triangle has to be at least 10 feet. Okay, or greater than or equal to 12 feet. Because of that, right, I can graph it on a number line here. As long as my base of my triangle is greater than 10, I know that my area of this brown patch is more than 60 square feet. And there we go. So this has been 4.6, multiplying and dividing to solve inequalities. Please make sure you're referencing this as well as the homework guide to help you out with your homework.